So hi everyone, welcome again to my YouTube channel Fitness Fit Computer Geek. So if you're following my videos recently, in the last two lectures I have done some Leetcode question on arrays, which was some easy level question and some hard level question. So hope you guys have practiced a lot of questions while following my approach, how I have shown you that you can approach this problem and you are able to solve some questions, and I hope you are guys doing well on that. Today's lecture is all about in this lecture I will do some solve some LeetCode hard level problems. Okay, this will be the last part of array, and after that we will look into some different concepts. Okay, so without further ado, let's hop into my LeetCode and let's solve some questions. Okay, so before going to that, one thing I want to say to you guys, like, don't get scared by the question that, the tag is hard. It's not going to be hard. It's just depend on how much you understand about the question, and that thing I will discuss here. I will show you the much detail of. I will explain each and line, every line of the question, so that you don't have any doubts regarding the question, and in the same way you can approach any other question. Okay, just try to figure out by looking into all the lines that is given. Okay, so there are so many minutes here. So let's get into the hard level. Okay. Okay, so actually you can see it tick here. Actually, I was recording this lecture earlier, but the audio was gone. My audio gone, so I have to re-record this lecture. So because of that, you can see the tick marks. But don't worry, I will be solving it from the beginning. Okay. So here the question. Let's now see. I actually erased the solution. Earlier I solved, so I don't want you guys to see the solution earlier because just some technical issue was there, as I already mentioned. So let's don't worry about it. I will go through line by step by step. So this is reducing disease. Okay, something called reducing disease. This is a high level question. It's safe has collected data on satisfaction level of n disease. Okay, safe can cook one dish at a time. So let me explain the first line. So this line is a safe has some dish. Suppose you have some dish like this one is like, suppose we have some like fish fry, suppose he's cooking, and these two he has something like this, suppose here noodles is cooking, and these three can be like, can be like dumplings. So he has three dishes. So what's the question saying, like, he has give some level to this satisfaction level, like, oh, on cooking this I get a satisfaction of this. Suppose it gets satisfaction level of 4, and it has 10, and it has like 5. Okay, something. This is satisfaction level. And one more thing, given that each dish take only one, every dish take 1 unit of time. Okay, 1 unit for this, 1 unit for this, and 1 unit for this. Okay, it is mentioned in the first line of this line. Kill it, you guys. Okay, so lifetime coefficient is something mentioned here. Lifetime coefficient of a dish is defined as the time taken to cook that dish, including the previous dishes, multiplied by the satisfaction level. Okay. So previous time is every dish have the time of 1 unit, and it is defined, this lifetime coefficient. This is given as, let me copy that line. So it is given a time into satisfaction. So suppose each this is taking 1 unit. Okay, suppose let me consider the array first. Okay, let me have the array and store all the three values. Okay, you will understand this way practically. So you have the value of 4, 10, and this is a satisfaction array. Okay, satisfaction array. This is the satisfaction array. So, and what is saying that lifetime coefficient here? Time into satisfaction of each element. So, how much time it takes? It's first, if you choose this 4 element first, it will take 1 unit of time. Okay, it's mentioned that every unit is taking 1 unit. So for 1 unit you are cooking. Now it is also the previous one is selected. See this, including the previous dates. Okay, so whatever the previous dish time was there, like suppose 1 unit time, when you cook the second dish, it will have the 2 units of time or not? 1 unit for itself and 1 unit for the previous dish. So it will be two. Okay, if you're getting it, hope you're getting it. Suppose you start cooking this dish at 0 unit and it cooked till 1 unit, and from then again this two came and he cooked till 2 unit. So in this way, so 1 unit total time of this two is 2 units or not. Okay, this is they are saying in the question. Okay. And for similarly, we have 10, 5 into 3. This is the lifetime coefficient of any element. Okay, suppose I element. This is given here. You can calculate this. Now let's see. So hope this clear. Till now, hope it is clear to you guys. It's simple, very logical things is happening here. And return the now it's saying that return the maximum sum of life coefficient that the ship can obtain after each frequency. Sum of life coefficient. And this line also like this can be prepared in any order. Okay, order is not doesn't matter, and you can discard some of these. Like some of these that is have some negative reviews. Okay, like negative satisfaction that he does not like at all. You can discard that is and calculate a maximum the sum of life coefficient. Okay, so suppose I am performing this in this order. Like I took this, then this, and then this. So what will be the sum of the life coefficient value of each element? What is this? Like 4 plus 20 plus 15, 35. Okay. So 24 and 45. 24 and 45. 69. 69 is the highest maximum no, lifetime coefficient sum if you cook this order. If suppose I cook in this order, like suppose I start cooking 10 here. So 10 will have again 1 unit time because you know this is prepared earlier. It is the first dish. Now in the second dish, the first dish is prepared. Now the time of second dish is added. And similarly this. So what will the value, this value we get? If you calculate, you will get like 10 into 10 plus 8 plus 15. What do we get? 18 plus 15. Okay. 18 plus 15. It will be like 33. Okay. See how this is happening. So in this order, you can discard this order. Suppose I don't want this, then you can cook this to this only. So how much life coefficient we can get? So we have to take every possible combination and whatever the maximum value we are getting, we just have to output it. So how could you do it? Okay, before going into the approach, let's see some test cases first. How could we approach this? It will be clear from here. Suppose this is the first array we are given. This is our array. Okay. So see this approach. Like, can you guess it? Like, what could be the maximum output? Maximum. How to get the maximum lifetime coefficient? How to get the maximum lifetime coefficient? It's based on the maximum, maximum satisfaction level and the maximum time. So if you cook this is at the last, then you will got the maximum value for this or not. Now the question, how can you do this? Like this is the maximum satisfaction level and maximum time could be what? Whatever time in order you perform. So maximum time into maximum satisfaction with the maximum life coefficient or not. So it will in this way we can maximize this problem. So it's a greedy approach. I will get into greedy algorithm later. So that's for now. It's greedy approach for maximum value. So for that purpose, you have to sort this array. So if you sort this array, what will you get? The satisfaction level will be in increasing order. So now you get a satisfaction level in increasing order. So you're getting it. This is the highest satisfaction level, and if you try to cook this manner, it will get the highest time also. So in this way, you can maximize the lifetime coefficient, sum of the lifetime coefficient. So suppose you discard, suppose you use all the numbers. So it will be like -9, -8 into 2, it will be 16, -1 into 3, it will be 3 plus 0 into 4 and 5 into 5. So it will be 25. So this is from negative number it will come. 20 minus 28 plus 25. This is -3. And it's not efficient, you can see. So if you discard it and consider these four elements. So -8 into 1 plus so suppose I discard the first dish, then I get -8 into 1. Then the first this is this a -1 satisfaction level into this one into now. Okay, this somewhere now. So plus -1 into 2 plus 0 into something. I don't want to write it. So 1, 2, 3, 4. See here. What will you get? You get -1, -2 plus 20. You will get minus 10 here. 10 is the satisfaction level. See, you can optimize this or not. Suppose now I discard these two elements. Now consider these three only. So -1 into 1 plus 0 into 2, then 5 into 3. So you will get 14. See this. This is the maximum you can get. So this is the maximum you can get. Okay, you can try it out. Like suppose you discard this, then 0 into 1, 0 into 1 plus 5 into 2, you can only get this, only 10 again. But this will be the maximum. You can see this anywhere. So if you discard these two elements. These three will give us the maximum value. So what we are getting it here, we are trying to every possible combination, like we are looping through this array and trying every possible combination. Whatever we are getting the maximum value, we are just update the value. Okay, this is the approach we will follow. Okay, so let me show you how to do this. The approach is very easy, guys. Okay, hope it is very clear. So what could be the approach here? First approach, we need the, first we, what are you gonna do? Like we have to loop through the array. So we loop it for I equal to 0, I less than the size of satisfaction array. Okay, whatever the given in the function, we will increment this. So this will be like, this is our first array. And before going to this approach, so let me show you that how this approach is workable. To see this, the constraint here. The constraint is like, this constraint has only 500 values. Okay, so 500 value, like, can apply n cube solution also. But in our case, n square is efficient, n square is sufficient. So I will follow that. Okay, I will show you how to approve. Like why the n square solution? Like first is the, like, you have to loop through the array and compare each element. Like, taking the value of once all element. Now you discard some element, then again you run a loop. Then you discard some element, again run a loop. So it's n square time. So every element is checked, and whichever a combination of element giving us the maximum value, we will just print that. So firstly we'll sort the array also. Na? We will sort the array. After sorting, we will run a loop, and inside a loop, we will declare one variable called time. It will calculate the time you are using. You know, means whatever time you have to declare time from one, because time, each this is taking 1 unit of time at least. So we have to take one is the beginning of this time value, and we can have the another value like, int like what you gonna lifetime coefficient sum, na? So sum life coefficient, sum of life coefficient. So you can initialize this to 0. Okay. So each time now we are have the 0 value, and we will compare for every combination. Okay. So how to do it? We have to run a loop again. So for int j equal to, can you guess it? What could be the initialization value of j? So suppose the list begin from the, so 9, 8 minus again the previous one, 0 and 5. So you can do this manner like, firstly you will, if you I is here, then you again start comparing from here. We take this value, then multiply with time coefficient and calculate it and sum it up. Now again, when the I is incremented, I is becoming pointing to this element, means this element is already discarded. So we can start again from this, comparing every element. Okay, so for this, we'll start from I. Okay, hope this is clear to you guys. And I is again less than size. Why you have to look through the entire array? Okay, it's J. Sorry, don't make this mistake. J plus plus. So what's it gonna do here actually? What's it gonna do here? We actually gonna sum it up. This variable we have to sum it up. So sum of life coefficient value what? We already know the one life coefficient value is given by time into satisfaction level. So we will do that equal to satisfaction array, whatever the satisfaction array we have. So satisfaction array we have. So we'll multiply I with which will multiply with time. Na? And we have also have to increment the time, because one, if first one dish is selected, it will be 1 unit time. Then second dish selected, it will have the value of previous dish value, that is 1 unit, and its own cooking time, that is 1 unit. So it will total 2 units. So we have to increment time whenever we select the satisfaction level of, is this. So this will give the coefficient. Now we can take one variable like, final maximum result. We want to get the maximum result. We can take one variable and just calculate a maximum outside this loop. Why outside this loop? Because one loop will consider the one combination, then again another loop contain after discarding some element what the other another combination. Okay, other combination. So hope it is clear to you guys. Okay, please mention in comment section it's not clear. I will explain it again. Okay, or try to think like you. I'm just showing you how to think. Okay, so max of what? Max of this value. So max of this value, and the you will slide this to 0, and it will automatically update the maximum. Okay. So after finally coming out of the I loop, outer loop, we will just return this value. That's it. Return this value. So this is our basic solution. Okay. Let me get it in one screen. So this is our basic approach. So we just firstly sort the array. Okay. We'll first sort the array, then we loop through it, and we declare two variables for calculating the time and calculating the sum of life coefficient of each combination. Okay, so this is for combination. and each combination we will do this manner. Okay, hope this is clear to you. After doing this, we will just max it out, get the maximum value, and just to print it. Okay, that's the three things we have to do. First sorting, then looping, then finding the coefficient, and then maximizing it and return it. Okay. So hope it is clear to you guys. It's very simple question. Okay, logical question. So let me now code it out for you guys. So first we need the size of the satisfaction array. SATIS. And what you're gonna need, we need the result. So maximum rest will be the final result. We'll decide this with 0. Then we just start looping it. Okay. So we just start the inside loop. Inside this, we need the two variable. Okay, as you declare the time, which will be time should be start from one. Okay, because 1 unit time. Okay, and we need another variable for int life of his sum. It will calculate the sum of each combination of lifetime coefficient within the which is equal to satisfaction of I into time of I. Okay, so we'll now start the second loop into j equal to I, j less than n, j plus plus. What's it gonna do here? It will be a simple one thing. We just let me copy this and try to naming this variable in this manner, because in other time you can take and later and understand your solution, like why I taking these variables. Okay, if you don't arbitrarily name anything, it will be best practice for you guys. So you know, later point of time you can understand the code. Plus equal to what? The satisfaction array. Let me copy this now. I don't want to get any typo. Type satisfaction array into what? Into time now. Time, and we increment the time also, not for each disk time will increment. Suppose first disk will taken 1 unit time, second disk will be the first disk pair, previous disk time and its own time, that is 2 unit time. So it need to be incremented. Okay. So this line kill it you. After coming out of inner loop, what you have to do? You just have to maximize this value. Max res equal to what? Maximum of um, max res and that value. It's this, we update this value every time, every for every combination. Okay. And can you guess that one mistake return? Let me do this. Can you tell me one mistake I've done? Actually, I haven't sorted the array. So don't forget this to sort the array. So I don't want to be type 4 to copy this dot beg and in the in. Okay, you can check the STL function from from the GitHub list. Okay, this is the way you can sort it. In one line sorting function. You don't have to manually sorting, apply any bubble sort or mass sort. Hope the beginners might not be familiar with this, but yeah, this way you can sort it. Okay, let's see now. Solve it. Test that we get everything correct. Okay, we're getting wrong answer. What is happening? Okay, might be. See again. It's I na. It's the inner loop na. So again, so let's see. So, okay, so now you can see that it passes, and let's now submit it, guys. Let's see. So you can see that it be the solution. Okay, the same thing, an earlier question I've also done. Okay, don't. So this is the our next question. So you can we are here actually. Okay. So hope this question is clear to you guys. Okay. Now moving on. Let's solve this question. So this question is all about it's some of the things you might not understand. So I will not completely solve this question, but I will give you hint how can you solve it. If any of the users know that you can how they know the concept they can apply. Since I'm making this lecture for very for beginners also, I will not get into the backtracking and TP actually. You can solve this in dynamic programming and backtracking here or recursion, mere recursion also, because the question are very low. I will show you that. Okay. So, so I will get no try to solve as much as array involved. And no, this question some of the contexts are from array and mapping, so which we have already discussed. So I will discuss that point, and I will give you the concept that how can you do it. You can Google it out how to approach that. But when I will teach the recursion, then again I will come back and solve this solution. Okay. So for that now I will just solve this now. Okay. So what this question is saying? Let's see. Second question. Given a list of words, list of single letters, and can be repeating also, and a score of every character. Okay, there are three arrays are given. List means array here. So words, there is an array of words, there is an array of letters, single letters, and there is an array of score of is alphabet. So these three arrays are given. Now this is showing like return the maximum score of any valid set of word. Any valid set of word you can form by using the given letter. Whatever letter is given, we have what is the maximum, maximum score of that word we have to find. We cannot use two or more time. Okay, the word we cannot form the using the same letter two or more words. Okay, what even letter array is there? We cannot use the same letters, same frequency of letter to form the same words. Okay, so this is not allowed. It is not necessary to use all character. Okay, some of the letter might be missing. If you get the maximum value, leave it out. Okay, and each letter can only be used once. Okay, it can only once use its frequency even. Okay, I will get it again. The letter of ABC is given a score of 0, 1, 2, 3, 25. Okay, this is what it's given. Okay, so check the first. Let me explain the first test case. Okay, three arrays are given here. So this is our array is given. Okay, the first input. Okay, I will explain you this now. Like dog, you know, okay, dog, cat, dad, and good. These are the set of words given. These are the letters. Okay, A, C, D, E, O. So we have to find a valid set of words. Means words can be more than two. Valid set of words. So we have to find a valid set of words that's using this data we can form and we can get the maximum score. Okay, score is given here for each one. So suppose I select dog. Can dog be formed here? Like a D, 3D is there. So we can use 1D. Okay, so remember this. How to just calculate the frequency of this. A is 2 here on letter word. C is 1 here and D is 3 here and G is 1 here and O is 2 here. Okay. So let's see, dog is formed. Can be dog required 1D, 1O, and 1G. Okay, dog can be formed. And how what can we combine? Can we combine to cat here? CAT? No. See this. T is not present here in this letter. So this word cannot be formed. So can we form dad here? Dad required 2D and 1A. So 1D is already used. So there are 3D. So 1D is used, so 2D will remain. So using 2D, we can form double D and 1A can be used. Okay, 2A is there. So we can form this set of word dog and dad. Okay. Can we form good after this? No, we cannot. Why? Because D is 2 here and G required 2O, but you already use 1O. Okay. So it is 1 here. Na? So you already use 1O and 1G you can do. Okay. D is, but O you cannot get. You need 2O. So good cannot be formed. Okay. So only this combination are possible for one valid set. Okay. Let's see dog and good. Can dog and good be formed? Three O's is there? No, dog and good. But dad and good cannot be, can be formed. Like dad is like dad require 2D and 3D. 3D is there and 2O, 2 are also there and A is there. So okay, dad and good are sorry, not dad and good are the another combination. Okay. So now these are any two combination can you get? We can only get. So we have to find the maximum score of these two. Okay, hope it is clear to you guys. So maximum score, how can you get? Right, this is the score for A, B, C. So C and D. So D we need and O also not A, B, C, D, E, F, G, H, G is lead. This is the frequency of G. J, value of G, score of G, G, H, I, J, K, L, M, N, O. O is given 2. P, Q, R, S, T, nothing. So O is given and G is given, D is given. We need only these two and A also. So A, D, and G and O. So what is the score? This is doctor. How many? What is the formulation here? D is 5 here. So 5 plus O is what? O is 2 here. 2 plus what? G. G, what is the frequency value of G? G is 3. This is for first word. Then we required for the second word. Second word D is again 5. And A is like, A frequency has 1. And D again 5. So what is the combination we will get? 5, 5, 5, 15. 15 and 5 again. 21. Can get 21 here. Now let's see this combination. Dad, like, let's see this combination. Okay, dad, D is like, D have 5 value. Okay, let me, yeah, let's see this combination now. So see, D has a value of 5 here. Okay, 5. So we'll add 5. 5 plus A has the value of 1, 1, D and again 5. Then G. G have the value of 2 and O is 2 times. What is the frequency of O here? C. It should be G. No? G is 3. Sorry. G is 3. And O is 2. Now to 2 times you add then D value. D is what? D frequency is 5. What are you going to get here? So you get 5, 5, 5, 15. 15 and again these two 5 20 22 23 23 you will get. So this will be the maximum. You see this, you get 21 in one case and 22 in other case. So this is the maximum. See the answer. See 23. So this way we'll solve this question. Okay, so frequency matter, like frequency of what is given. You can use 2D but 3D, but you cannot use 4D here. That they mean by this line. This was letter cannot be can be used. This actually referring to frequency of letters. So, okay. So how to approach this problem? Okay, how you gonna approach this problem? Let's see now approach. So for approaching the problem, firstly you need to collect the frequency of all the alphabet. To A to Z you have to make a map. Otherwise you will forget it. So you have to mention a map like first map will be what? Map like alpha. Suppose make it alpha. It will have the character value and we will add the score of that value, the int value. Uh, Map alpha. Okay. Okay. So we after this okay, syntax error. This will be alpha. So this is the map we need, and we will fill this map. Okay. Hope you know how to fill this map. Okay. We will look through the score array. So from auto I, suppose auto I in you know the score array. So we're gonna fill this array. Okay, so how you gonna fill this? Map of sorry, not map, alpha of I. Okay, so how are we gonna convert this? This is one more thing. Like I is there, so I can begin from one here. Okay, this loop won't work. So like we have to run a loop like for int I equal to 0, I less than 26 because 25 later 0 to 25 26 later, and I plus plus. So this is our loop. So entire loop we're gonna fill this map. So alpha of I is what? Whatever the value. So how to make it like character? Like if you add a here, so it will get the ASCII value of a and store it in alpha. So you can score it as score of I. You can store it here. Okay. So score of a will store then a plus one. A plus one means what? So whatever the ASCII value of a, then one is added. So it will be like B. So in this way, its array will fill. So alpha array is filled. Now one more thing you have to do. You also have to mention this one, na, this mapping, because you will have to use this mapping to loop through each word and get the map. So again, you have to define one more map. Okay.
So as I was saying, how you can firstly, as I shown you, like you have seen this, that first enter all the the values of, suppose there is have some 5 and B has some some score, that is 3, and C has some score, that is 2, and so on. So you create a map for this and store all the store. Okay, so this is the way you gonna store the map. Now what are the words you are forming here? See the question. Let's see the first test case here. Okay, so dad and dog was forming, no? Like three D's was there. Only one, two, three. So dad and dog will be formed here, and dog individually and dad individually, and the dad and good will be formed. But dad, good, and dog will not form. Okay. So let's try to do this. Which one is giving us the better value? Dog or dad, or you know the good and dog, good and dad. So how we are solving this actually? So like I was saying, um, so like the words were forming like this, na, like the words were, let's see the words. So words are like dog. Okay, dog and dad is one pair which can form and which can give value, and another pair is like dad and good. Okay, so these are the word study forms. So how we gonna do it? So we also know that the the alphabet, the values of, what do you say, and the frequency of letter. The frequency of letter also matters here. So we should have another variable of map, that should store the frequency here. Okay, hope you're getting it. So we will have another variable like suppose map, it will have the character char, and it will store the frequency as integer. Okay, so we'll form this map. Okay, this map is and we can call this map as letter map something, mp, letter mp is correct word. So how we going to do it actually? So how we gonna fill it? So we have the letter also, let's bring that also. uh, so these are the letter. Let's copy this, let's make it bigger. So we have the letter, this one. So we will create this map. How we gonna create this map actually? So we will, so the map will look something like this if you iterate through it. So so for so we have to iterate through it now. For int I equal to 0, I less than the letter dot size, whatever the letter dot size array, letter dot size, we have the letter word. Okay, letter dot size, then we increment I plus plus. Okay, so this is the thing we will do, and we will map it through like letter of letter mp of what character, whatever character we are getting to, you can do it directly like letter of I. So it will do the character map plus plus. So this will calculate the frequency. Okay, hope you're getting it. So what will the frequency of the frequency array form, what looks like? Let's see that. So A will have 2, you can see that, and C will have 1, and D will have 2, and G will have 1, and O will have 2. So O will have 2. So we have the frequency array with us. So this frequency array is like, will to give the letter of the words. So we have two words now, as I shown, dog and dad, two pair of words. It can be many pair also. So many, all the combinations should be possible, but these combinations are giving us the only result, and dad and good. So how we gonna use these words to get the frequency value and check whether it can be formed or not? So this is our issue. So and here we already have the score, so it doesn't matter. So actually what will we do here, like dog, dog, and can dog be formed? Let's see, dog log required 1 a. So how, what can you do? Like you can iterate through this map and check whether this D is present or not. First you have to form the pair first. So only issue is like how you form this pair. So there are actually three words, dog and cat, and four words actually, if you remember, dad, cat, dad, and good. Okay, so these are the four words. So these are unique words. So every combination, firstly we will approach like this, that we have to design every combination. What can be every combination? We can be dog only, cat only, dad only, or good only. Okay, or we can have dog, dog cat, dog cat, dog cat, dog dad. Okay, and dog good, dog good. Then we can have uh, cat, then we can have cat, you know cat dad, cat dad. We can have cat good. There are two combinations for that. And we can have dad, dad good is already not there, dad good, dad dog is there, and dad cat is there, so it's not repeated, is not allowed, doesn't matter. So and dad, which because it's the same value. So dad good and dad dog not, dad cat is not required. Dad cat is there, good is there. So these are the, and we can now form the three pair at a time. We can form like dog, cat, and you know good. We can form dog, cat, and dad. We can form dad, good, and dog. So these are the pattern we will form actually. So these are the pattern we will form. Okay, let me show you in one skin. See, there are how many combinations? 1, 2, 3, 4, 5, 6, 7. Let's count this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 combination can be formed, and we have to check which combination can be formed first. Then our first goal is to check the which combination form will form, and second goal is to check what is the maximum of the frequency we are getting after forming the after forming the pairs, or you can say, yeah, pair, not pair, after for forming the combination. So first thing is like how many combination possible. So first problem is like how many combination possible. This is our first problem. Second problem is like maximum of this, maximum of those. So this is, so this part is like, this part I'm talking about. This part is or required higher knowledge of it actually. This part required the knowledge of backtracking actually. Backtracking DP, you can have DP also. Backtracking, DP, and recursion is recursion. So recursion, how recursion? Because we will combine every pair and take do it repetitively. So I haven't taught you recursion, so this part is remain mystery. So once you found the pair, you can do this. So I can show you how to do this, and when I get into these topics, I will solve this problem. Okay. So see here. So these are given, and like suppose we have formed this word. Okay, we have formed this word. Now using this word, we have to iterate through the map. Okay, and find the map. The find value will help to iterate it, like one way. So how can you do this? Let me show you. So we can do this way, like dog is there and dad is there. So firstly we take this word. Okay, so for combination of word, we take this word. So for for now we gonna iterate the map. So for auto I, letter of MP, right? So what's we gonna do actually? So if we iterate through this, actually we don't need the iteration. Actually, yeah, it's not required. You can do this way. So we iterate through the word like dog. So what we're gonna do? So we take the letter dot letter MP dot find D. Is D is there? So we'll check this D. If it is not the end of it. So if D is present, to find operation we can find it. So if D is present, then we increment, then we decrease this D by 1. So firstly dog and dad form actually three frequency there, or D, I guess. Yeah, sorry, dog is three frequency. That was thinking. So 3. So it's three frequency. So 3 it become 2 now. So come into this. So we'll find this D. Okay, so if this is present, then we decrease the frequency. Okay, and we add the value of this. So how can we do it? To we can again then find the letter not. It's the name of the alpha, na, alpha, where the score is stored. So alpha dot find D. So if we will obviously get this value. So what we'll do, we take take one variable called x. We can temp variable or something we do and increment it. So once we do it, we decrement from the map, and you increment it. So how to decrement from the map? So we can use this letter MP dot second will go give the second value, MP dot second minus minus. So it will decrease the value. Okay, it will decrease the value and increment the count. Then we will go for this O, who have put this way. So O, now we no iterate through this word. It will be double loop actually. The once the array of the word, second in the each letter. Okay, so O is there, so O again we will do 1. Okay, increment, will increment it, so x will become 2 here, and it will decrement, and then now x will 2 here. Then now we go for G. So we go for G. Is G present here? Okay, G is present here. We make it 0, and it will increment by 3. It's not increment actually. It's actually the value of no, no, it's not 1 actually. It's the value alpha dot second. We actually what we're doing actually alpha of second, no? So we will like add, well, suppose just 1 2 3 is given, okay, for say for simplicity we just add those values, okay, whatever the values of D, O, G and present, we will add those values, okay, whatever, let's get to the actual value. You will get confused, or the D is like, let's go above and see the what is the actual value of D in dot. D is like, D is here 5, so actual value of D is 5 here, and let's see the O also. So D is 5, so actual value is 5. So firstly D is 5 now, the 5 will add it 5 plus what is the actual value of O and G also. O, G and A, let's see. O, G and A. O is here, O is 2 and G is 3. O is 2 and G is 3 and A is 1. O is 3, O is 2 and G is whatever the but okay, so we increment this, so it will be like 10. So it will 10 here x. Then we iterate through this word only, and we will check this. If the frequency is not 0, D, okay, frequency is not 0, it's 2. 2 will decrement it, and we increment the D value. We can use 5 again for D. Okay, then A come. A is like frequency 2, so we can A can also be formed. So 1 will be there. So it will add the whatever the frequency of that. So for A 1, and D is there. D is again 5. So now this is added, so 15, 16, 21 we get from dad and dog, and let's see from what we get from dad and good. So we'll follow the same approach. So what we're gonna do, we then store it in a max result. Okay, result will be like max of what, x is there, whatever value, final value of x outside this loop. Okay, outside this loop, and the value of max res. So in this way we'll store the maximum value, then we again loop through it. If this one this one give the value more than this, then rest will be maximum, and finally we print the maximum, max rest. So this will be our result. Okay, this way we will solve this question actually. So what we're saying, like, this is the this factor we haven't is so that it cannot be done, but rest problem you can solve. Okay, so hope you are able to visualize this question. It's very simple question, just some logic is involved. Okay, so I will come into this question later when I taught you recursion, and I will solve again. Okay, for now let's see the other question now. Okay, thanks sir. So if you want to check, like, you can do the coding here. Okay, whatever I written here you can do the coding. Was the part will the pair forming. Okay, this was the only part. Okay, now let's see some other questions. So reducing this is done, maximum forward data, let's see, so not uh, let's see which one I can solve. Choosing that one, where is gone actually. Let's see, yeah, this one. So this is the one of the interesting question here, but if you have done some of this thing, like logical, some of the this problem is like real world problem. See this problem, you will find this problem interesting, very interesting problem actually, this one. Okay, let's see what's he saying. So what's it saying? So you have n flower seeds. Okay, you have n flower seeds. You have n flower seeds. Okay, every seeds must be planted first before it can begin to grow. So it is obvious, genuine, it's a obvious thing, like firstly you have to seed it, then it can begin it planted, then it can grow and then bloom. Okay, it's a general process of planting a tree. So planting a seed takes time, and so does the growth of the seed. So they are saying that, okay, of course you have the seeds and it will take some time to put the seed inside the soil. Like you put this first you dig the soil, then you put the seed, then you cover the soil, then you water it or provide with the essential nutrients. So it will take time. and so that the growth, of course the growth of seed will take time, it will take days to grow that seed. So you are given two zero index integer array of plant time and grow time. So plant time is given, like planting is seed time, and grow time is given of each of length 1, each of length n. Okay. So now let's see what is the plant time here. It is the number of full days it take you to plant the ith seed. So what is the number of full days, like not half days or any day, quarter days, it's like how many full days it actually take to grow this plant. So it's like how you are seeding this plant, then how much time it's to plant the seed. Okay, how much time, sorry, it's how much time it take to plant your seed. Every day you can work on planting exactly one seed. So this is one of the most important thing. The planting can be done exactly on of one seed. You cannot plant two seed at same day. This is the question given. So you same plant can grow at the same time, of course, but you cannot plant two seed in the same day. So this is the one of the important thing you have to be kept in mind, that you know you cannot, you can work on planting exactly one seed only. You do not have to work planting the same seed on consecutive day. This line is redundant, and I can say you this line is for you and misleading. Okay, actually this is not required, actually this is not required information, but they are given you. So yeah, but the planting of seed is not complete until you have worked this much time. Okay, so all the time you have to do it, and you, it's not necessary to work consecutively. That that they are saying. Now let's see the grow time. Hope you understand the grow time, growth plant time. So grow time is the number of full days. Number of full days it takes ith seed to grow. So number of full days it takes the highest ith seed to grow after being planted. Okay. So grow time in number of full days take the ith seed to grow after being planted completely. After the last day of growth, the flower blooms and they stay bloom forever. So see this. The growth time is actually the whatever the actual growth time plus 1 day more. So this thing also have to be kept in mind. And stay bloom forever. From the beginning of the day zero, you can plant. So day zero, we are starting to plant seed. You can plant the seed in any order. Return the earliest day where all seeds are blooming. Okay, that is they are saying. So we can copy this image. Let's see this, and let's take this value plant time grow time, and let's find the, and it's just saying to return the earliest possible day where all seed are blooming. So what is the minimum day it take to grow the seed? That is the only question here. What is the minimum number of day it will take the all the seed to grow here? Okay. So all the, like suppose you start planting from seed from 0 day, and from plant from from planting some seed from 2 to 3 days or any day. So what is the earliest day that all the plants will grow? So this you have to find. Let's copy this. I can show you this example once how they have solved this question. So plant time is given, and this is the growth time. Okay, and you have to find a minimum tree. So how they are planting actually? See this. The 2 is the growing time. Suppose this is the first seed, this is second seed and third seed, and its grow time is given. So first seed take 1 day to first seed take, you start from 0. So first seed will take 1 day to grow. Okay, here it is shown that 1 day it's taking 1 day to grow. Then they are doing like so they are doing like they are planting this tree, and it is taking two days to grow. So it's so that, so for 1 and 2 it is growing. See this, it is growing, and finally it is blooming. In day 3 it is blooming. Okay, something. So you, in the same day you cannot plant this the second tree or whatever. So if you start planting the second tree now, so if you plant starting second tree from second day, 1 day only actually. So you will plant this tree here, you cannot plant here. You plant here, it will take 4 units time. See planting time 1 2 3 4, it will take 4 units time, then it again take 3 units time to grow 1 2 3, then it take the final day. So what is the result here? 3 4 5 6 7 8 9. So 9 is taking the max, 8 is taking the maximum. Okay, I've done something wrong. 3 days 4 days to grow, and 3 days to sign. Okay, in 8 it is finishing. Now for the third plant we can we cannot in 3 days. See this is 4 days taking time. In entire 4 days we cannot plant any seed, because only one seed can be planted in a single day. So we can plant from third seed from here. So it will take 3 days and 1 day to grow and 1 day to sign. So it will total take of 9 days. So 9 will be the earliest date that all the seeds will be blooming. So this is the one way to do it actually. So what can be the other way you can do it? Suppose I sort this suppose I able to sort this. Let's sort this. Like you might have guessed, like if you take the longest seed, longest time and longest growth and plant time of a seed, it will give us the minimum earliest one, because that is the plant only take the maximum amount of time. So on the maximum amount of time we can plant the minimum the other two which are shorter than them in the interval that it is taking time for growth. Okay, at that interval you can plant and we can get the minimum earliest day. This is by possible. So it is like longest job soft, we will get that longest job which will have the longest, which is taking longest time to get their job done, then we can do it simultaneously. So this is the way. So we will do it. So we can sort this in any order. So suppose I sort in growth time basis. Like if you sort this in plant time basis, like if you suppose you are saying like, okay, let's sort this in plant time basis, like so if you look it, like if you try to plant it, if you try to plant the seed, yeah, so if you try to plant the seed in this way, like the plant time more, which one is choosing, and suppose let's suppose do that way. Actually, let's suppose we are getting the result or not. Okay, try to sort this in you know this way, and 4 is 3, 3 is 1, and 1 is 2. Let's see what will happen. Is it giving us the correct value or not? So on 0th day you can plant this seed. So if you start planting this seed, actually it will take 4 days. 1 2 3 4. So it will be like 1 2 3 till like planting time. So you cannot, all the 3 days wasted, actually you cannot plant the seed in that interval. So this is, we cannot take the longest of this. Okay, we can take the shortest of planting time and longest of growing time. So in this way, the longest of growing time, in the longest of growing time you can plant other seed which can take their time. So it's, you are getting it, it's logical actually. So in the planting time, it's actually, you have to see that you cannot, you have to kind of stall here. Okay, in CEO, in pipelining, if you have gone through the pipelining chapter CEO, you know that we are stalling here. Okay, actually you are stalling here. So in this period we can utilize this also, but if you sort this way, all the 4 units will be entirely wasted here. Okay, this is what I mean here. But if you choose, like and if you sort in a growth time basis, so in the growth time phase you can plant the seed also or not. So in that way you can utilize more. So this is not the correct way to do it. Okay, hope you're getting it. You might have think like, let's sort this in plant time, and rather than growth time. But plant time, you can see on plant time you cannot plant any seed during that period, because this is stalling period. Okay, so let's see that if you if you plant this in on growth time, what is, we sort this in descending order, 3 2 1, and what is the 3 value plant time of that second one, and 1 plant time is 3. So let's suppose do this. So now I will see the result. So this is the growth time, actually growth, and this is the plant time. What you gonna do, you will plant this seed first. Okay, suppose I plant this seed. So planting will take 4 days here. 1 2 3 4, 0 1 2 3. In fourth, after fourth day you start planting the next seed. Next seed, like next seed is what, uh, it will let it grow. Grow time is 3, so it will grow here. 1 2 3 4 5 6. So in 7 day it will bloom. Okay, so during this time you can plant this seed. After this you can plant this seed. See, so I planted the first day. Now see this, see the second seed here. It take 1 day to plant. You can plant here, and it will immediately start growing here, and it will also bloom in 7 days. So now see this. So third tree is plant time is 3 days, and we cannot plant here. Okay, of course you have got it. So we'll plant here. So we will plant here, and it will take 3 days to plant. 3 days to plant. So till 7 it will be planting, and in the 8th day it will be glowing. It take 8th day it will growth, and on 9th day it will bloom. So see this, it's take only 9 days. And if I sort this in the plant order, like suppose 4 3 and 1, let's see how much we will get here. For 3 it is 1. So this is now the plant, and this is the growth. Let's see this also for your explanation, you will be clear. Some guys might have doubt. So growth time is 3, plant time is 4. So first again it will plant it. This will go for same 1 2 3 4. it will go for same, and then it will take, actually it is taking 0, 1, 2, 3 to 4 days to planting and 3 days to growth, to 4, 5, 6 to 4, till that it will be growing. Okay, and in the last day it will bloom. In 7 day it will be blooming. 7 day it will be blooming. Now if you choose, now this interesting thing will come here. Okay, see this. So if you choose the second plant here, and planting time is 3 days, so it will again take this all this time to plant here. See what is happening here. In this case we are able to plant here, but in this case this is stalling here. Okay, it so it's like, in installing day you cannot do anything, you cannot plant that third seed here. Okay, see here, what is the issue here? You cannot plant that third seed here, that is the only issue. So if you suppose it have only one day only, you can plant it here now, so three plants simultaneously growing. So in this case it is not happening. See this, three it is taking plant, then it can take 1 day to bloom, and in 8 day it will be blooming. Now if you choose the third one, plant time is only 1 day, you cannot plant here, you can plant here only, and it will take 2 day to bloom, 8, 9. On a 10 day it will be growing. Okay, see this, 8, 9, 10. So see this, it is taking much time. So this is not the correct way to do it actually. If you might be logically thinking that sometime if you change the number, we might get the result. Yeah, I agree with that, but it's not, it's valid solution. Why? Because when the plant tree, in a long run, on the seeding time you cannot plant any seed. You are seeding, you are, you take the seed and start, digging the hole and put the seed. Then on that period you cannot dig a hole and put another seed. So for that time it will be completely wasted, it will stalling. So for the stalling part, this part won't work. Okay, this part, won't work, this will only be applicable. Okay, so what you got here, if you sort this in on the base of growth time only, so what is the longest one will grow, it will let it grow and it will bloom. At the same time you can plant the other trees which can take lesser time and it will grow. So it will be maximum utilization of space actually, the time actually. So hope you are getting it, hope these two are very clear. These two case should be very clear for you guys. Okay, how are we gonna sort it? Okay, so now we have seen this, let's see the approach. Let's see, before that let's see the constraint. So see, this 9 is coming now, and take this example. This example is quite a misleading actually, this is quite misleading, so don't get into this. Okay, they will likely stalling, they unnecessarily they are stalling and somewhere planting something, they just want to get the plant done. So you cannot, don't rely on this actually, rely on the longest job first approach, like, let the plant to grow which have take the longest time. So it will net during that time we can seed the plant, the other seed, we can seed the other trees, and you can let the tree grow in the same time. So in this way the space, the time is more utilized. Okay, hope you are getting it. Constraint saying growth time 10 to the power 5 here and 10 to the power 4. So any standard power 5. So what does this mean? We can read it's required n order of n solution or order of n log n, not more than that. Or more than that it will be fail. So let's try to do it. You can see that there is order of one solution is there. So how are we going to approach this question now? Let's see this. So we have two arrays actually. So we have two arrays actually. One is the plant array and another is the growth array. So we need the plant and growth array at the same time. So what can you do? We can use the vector pair here. Okay, let me show you what is vector pair. You can read more from here. Okay, we need the vector pair here. Vector is for array, vector pair. If I suppose, let's talk about pair first. Okay, you can check it here. What is pair? Pair is kind of some data type. It's a store a pair. Okay, so it's like there are two element of it, that first and second. For through this we can access the data of each element. Okay, this is how we are doing it. Now we have to see that how to sort it actually. For sorting purpose we all know that, like if you take vector pair, that earlier example is come, vector pair, and here sort the vector pair. So we can take, we need the vector pair actually, and how we're going to sort it. So the make pair is a function that can make pair. Okay, remember it, it will make the pair whatever pair we want. Okay, this is the way. So now sorting is there. Let's see the these are by default these sorting are based on ascending order only. Okay, if you see the result, yeah, it's only ascending order only. So how to do it in descending order? There is one example given actually. Let me show you that. Okay, see this descending order. This is the given way descending order. So how to sort it in descending order now? So it's not complicated, but yeah, let me see you show you how can do it by second pair, because we want to sort it based on the second pair. Na second pair is a growth time, because and we want to set them in descending order. So how they are doing it? So they are passing an extra argument. You can see the sort function here. If you match with the previous one, it's passing extra argument. What this extra thing is doing here? See this. It's kind of boolean function that taking two pair on it. Suppose two pair are taking, like, one pair is 4 3 and one pair is like, you know 5 1 something. One pair is 4 5, or second pair is 5 1. So now, uh, so it will take the second element second and compare those second element, like 5 4 1 and 5 3, to which one is compared. 3 and 1 is compared to which one is bigger. 3 is bigger, although 5 is bigger in first place. It doesn't matter, it is sorting based on the second pair, part of the second pair. So it will put 5 3 first and 4 1 second. Okay, hope this is getting it. Just comparing the pair here, the second part of each pair, and they are sorting it in descending order. So we will use the utility function to sort this in descending order first. Then after sorting it, we can apply the algorithm, whatever I shown you here. Okay, in above, where is that? So we can apply this. How to sort this first? Firstly, we'll sort this array based on a growth time. So firstly, we'll take the make a pair actually. Okay, so we'll iterate over the what, any one of them, size of any one of them, because both are same. So we can iterate over any one of them. After iterating over, we can make pair here, make pair, make pair here. After making a pair, we are ready to sort it actually. So how are we gonna sort it? We'll sort the array. Sort on the basis of, the begin and end will be there, begin and end will be there, and the that utility function sort by descending order, that will return a boolean value. So it will sort according to the growth time in descending order. Okay. Now, what is the more approach here? Uh, so we have sorted array. Now we need the two things here. We will first compare the maximum, and one is for making the summation. So we can declare two array here, int sum, int like, it's cool, let's call it at not sum, you can say first, not plus, let's say seeding time. Let int seeding time. Seeding time is enough. Seeding time. So in slice width is 0. Then we will take int what, first bloom. Then which time is it blooming actually. So these two time are equally added. Okay, and when this added, we will get our answer. So we will iterate over the pair. Okay, for int I equal to 0, I less than n, I less than n, whatever the size, and I plus plus. What's we do here? I equal to 0, I less than n, and I plus plus. What's we gonna do here? Firstly, we take the seeding time. Seeding time is entered is what? Seeding time is the actually the planting time. Okay, planting time is given in, the first element, first pair. So we can do this way. What was the pair name? Suppose any pair we name p dot first, actually p of I, na, it is array, vector pair of array, which is p of I actually, p of I dot first. So first will given the, the seeding time, and after finding the seeding time, what are we gonna do? We just have to find the maximum value, and we will store this in this first bloom, max of first bloom, and the second factor will be the whatever seeding time in here, just add the seeding time with them and store the maximum value here. Okay, hope you're getting it. So first bloom is there, and first bloom plus the, the seeding time plus the second array. So we will add this here. Seeding time is what, and what is the blooming time? Blooming time is written in the second array, na? So blooming time is second array for p of I dot second, p of I dot second. This will be our second. So in this way, we will find the loop. Each time we will, take the value, and each time we will taking the first value. Then we are finding the maximum of both all the things, and finally we will get the maximum here actually. So 9 is there something for the first test case. So how this is possible actually, like first bloom is equal to max of first bloom plus shading plus first byte or second, this is happening. So how does logic work actually? So you might have think like in earlier I was doing like the shading time, planting time, and a growth time plus one more day is data. Why is one more day is added in this case? Can you guess it? When one more day is added actually, so actually actually it's a zero weight index, so it is like it is compensated usually, directly it is compensated. So shading time, if you take the value like whatever the array was there, let's bring that array back. So this was our array, let's copy this. 413 3 2 1 4 1 3. Okay, so 3 2 1 4 1 3 is there. So firstly, how this loop will work? So pair is formed actually. So 4, firstly it will take the shading time. Shading time is what? Shading time, this is the plant time, this is the growth time. So this plant time is shading time actually. Let's name it as shading time, say plant time only, it will be very confusing. So plant time, so plant time is 3 here. So 3 will be added to the shading time, plant time. So now plant time has the value 3 here. Okay, we're inside the first loop, we're taking this pair only. 3 is there. Okay, see this how it's compensated actually. So first bloom is equal to maximum first bloom shading plus playing time. What is the shading plus playing time here? Shading plus playing time is 4 here, so 7 will store here actually. So if you see like how it's growing actually, so 0 1 2 3 4 5 6 7, see this. So it is first 3 days it will be planting time, and for growing time it is taking 4 time 4 unit. So this is the growing time, and this is the blooming time. See this is covered in this or not? So hope you're getting it how it is done actually. It's because it start from zero indexing, so the plus one is already covered with zero indexing part. Okay, so 0 to 7 is means 8. So this is logical, very logical. Okay, try to think it this way. Okay, hope you're getting it. So this one is there, the first bloom. Now the maximum value of first bloom is yes 7, only 7 is there. You might be thinking that why we are using max here, we are used have to find earliest one, but we are calculating max there because whatever the maximum time of all the this pair will take, it will be our value actually, which will be the earliest value. Okay, it's might be some confusing, but try to think about it. Okay, like what is the earliest way possible to how to determine the earliest way possible depend on the what is the maximum time any plant taking to grow, and planting time whatever bloom, suppose bloom, maximum time it's taking to bloom, maximum time it's taking to bloom. So maximum time is the earliest one because if you if you let it bloom till the maximum time, then on from during that period the other tree can be came and sit into that and grow and simultaneously end. So in this way it is maximum taken. So now it will first bloom have 7 value, it will have 7. Now it will be incremented here. Okay, we will have the 2 here and 1 here. So again it will start planting now. How can it plant here? It will plant only from this only na. The shading time is 3 only. See here, shading time was 3 only. Here the shading time is 3, and here only itself we are adding the second value here. So after 3 2 is added means the hair is itself it is growing na. So cut it is seeding, sorry not, yeah, and not growing actually, planting. So in this period it is planting na. So it will be like now 3 plus 5 will be taken na for seeding part. 3 is there on the p of I of first, p of I of first is 2 here to 5. Now seeding time is reached till 5, so this is the seeding time for second value till we reach. Now we add in the second seeding time with the performance time. So it is grow for 1 day, it will like, sorry not 2, it is 2, it is 2 day only, it's 2 day. So 3 plus 2 is added, 2 days are added actually. So it's not actually, I've done wrong, it is like, it is taking 2 day only na, it is taking 2 day only, and it will grow for 1 day, and it will it will grow for 1 day, and it will bloom here. Okay, and if you plant this one 3 day, it is taking planting time 1 day, like it here you can plant, then it will take 3 days to grow, and it will bloom in 9 day. So this is 8 and this is 9. Okay, So this way it will still done. Okay, hope you're getting it. So 3 is there actually. The initial value is 3 here. Then see this how it's covered actually. So uh, 3 is there. 3 for the initial value. Now we added 2 here. So 3 plus 2. So seeding time become 5 here. Okay. Then again we add the second value. 5 plus 1, that is 6. That is 6. So see this. In 6 days is finishing or not. So our logic is working here. I don't. So our logic is working here. Okay. So 68 is going again. We have 5, so setting time have now 5, and it's again it's still 7, so it doesn't matter if it is grow earlier, it no it bloom earlier or not, maximum is 7 still. Now we have this third value, so again it will be, if 5 is there, no, 5 plus 6, it will become 6, the setting time becomes 6 here, and then the planting time is 3 here. See this, 3 6 plus 3 equal to 9, so it will increment it to 9. So this is the maximum value we are getting, and 9 day it is finishing also. So you're saying this, the extra 1 day is covering because of the indexing part. So it's a logical way. You might be get confused that okay, the setting time is 5 here, but setting time ended is 4 here, but actually the 5 is added for the extra 1 day here. Okay, so covering that 1 day. Hope you're getting it. Hope this is very clear to you, because if might have you might have seen other tutorials also, I know. And they haven't explained this way yet, like how they are doing it. I think they have done their logic, but it's very not very difficult to visualize this actually, to visualize others actually. So if you are able to look into this, is very good actually. And hope you do, if you don't understand, just grow and go in the, just watch this video again. Okay, so by saying so, let's start coding now. Let's make it a big skin. Hope it is visible to you guys. Okay, let's do this coding. So what's you going to need here actually? Okay, so we need a pair actually first. So we have to make a pair. First approach is make a pair, make a vector pair, because it's array. Make a vector pair. This is our first step. After making the pair, what's you going to do? We will sort this pair. Let's sort the vector pair. And after sorting it, what's he going to do? We just run a loop and check the condition and return the result to our logic here. So this is a 3 step we will do this part. Okay, let's try the first step. It's like, firstly we have to make a pair. So how are we going to do it? First, vector. Hope you've gone through the documentation of doing it actually. Vector pair. So we'll make pair here. Vector pair int comma int, and let's name this pair as plant plant bloom. So we have made the pair. Now we have to fill this pair. So we have to run a loop. I equal to 0, I less than n, I plus plus. So let's declare n also. In n equal to any size, any plant time of any, because both have the same value, na? Each value is n given here earlier. So in this pair, we will make this pair now. So plant bloom, as is a vector, we can insert using the pushback function. We can do it. Plant bloom dot pushback. You have seen the function that make pair is a function to making a pair. Make pair. So what's you gonna do here? Make pair in this plant time of I and the growth time. Okay, we'll make the pair as I told you earlier. Okay, so this is confirm. So this is make, this happens now. So this is process. Now what's you gonna do? The first part is over now. Let's do the second part. We have to sort this vector. Sort, what is the vector name? Plant bloom dot begin plant bloom dot end, and we will make the utility function sort by, suppose sort DSA something. Sort descending is correct. So let's make this function also. So it will return boolean value. So what you gonna pass here? You pass the pair here, na? Two pair int int like suppose we p1, make it p1, and we again pass pair 2 as int comma int pair 2. So we have two pair and we'll compare this. So how are we going to compare this? So pair 2 and two pair we have, like suppose 4 and 1 and 5 3. So we'll compare the second value of that. So if you write this way, p1 dot second, p1 dot second, anyway p1 is second is greater than p2 dot second. So if this is space, we will return this na. If this is true, then we return this way. So if the all the value have, you know, so suppose 4 1 and 5 3, so pair 1 is not compared to pair 2. So this is the way it is compared actually. So as we seeing, we returning this value, and we the sorting part is done here. Now we have to apply our logic here. Okay, so three part, this is the three part function. Hope you are getting it. Okay, let's design our logic on now. So we need the two variable as I showed. The planting time equal to 0, and the blooming time. So this is the final blooming. So final blooming, you can say final blooming, final blooming equal to 0. Now you run the loop, int I equal to 0, I less than, the pair size will be always same, I plus plus. So what's you gonna do here? So we will just, as I said here, just add on the value planting time plus equal to the what plus equal to the pair. What is the name? Plant bloom here is our pair. Plant bloom is our pair. So we're gonna take the first value, first element constant the plant time na. So we'll store this, not this way, first bloom I of first. So after that we find the maximum value, final bl. So these are so many observations based on this question. So final value equal to max of what? Max of final blooming, because each time we will iterate it, and the longest sub will be added here, and planting time plus what? Plant bloom plus plant bloom of I dot second. So and after that we'll return this value now. That's it. Done. Let's see it is correct or not. No syntax errors or not. Let's see that. This is a sorting logic. Okay, we apply the sorting here, then we initialize the size, and we take a vector pair, then we iterate over to make the pair, then we sort the vector, then we apply our logic here. Let's run it. So actually this is because of the static. Did not make it static here. So if you make it static, then you can directly call this person inside a class actually. Let's see this. So let's run this. Okay, so accepted. Case 2, case 3 also. Let's submit now. Let's submit. So okay, it's taking so much time, but yeah, we're able to do it actually. I don't know why it's saying this. This is the only way to do it actually, in best time. But yeah, this is our solution. Okay, okay, guys. So let's see the next question now. Question, can we Verifica? Nope, it was not that. Okay, let's see. Okay, this one we will solve. We will solve. This is a question directly, na. So that's why I'm taking these questions. So let's see this question now. What this question is saying? You are given a two positive array num and target of same length. In one operation, you can choose two distance indices ij distance, which is I and j between this range, and num of I equal to num of I nums of I plus 2 and nums of I minus 2. Two arrays are considered to be similar if the frequency of each element is same. Two arrays are considered to be similar if the frequency of each array is same. So what does this mean actually? To consider to similar if the frequency of each element is same. So this line is very interesting actually. So now let's see whether I will get into that. To return the minimum number of operations required to make num similar to target, the test case are generated such that num can always be similar to target. This line is also important. Okay, I will get into this. This is the array, this is target array, and we should in two operations we should be able to make this equal. And series, what is the frequency mean here? Frequency means if there are four ones, there also should be four ones there. That is the frequency of array, and each frequency of each number should be same. This is the case where this both array will be similar. Okay, so let's see this question. So let's see this target and num is given. So we have to convert this target to num in minimum number of steps. Okay, let's see. This is our question. So num is given and target is given. So let's see, all are even here. So one more thing you have to notice that the set of operation we are can perform like are only we can do nums of I plus 2. What more operation is there? And num of j minus 2. These are the operations we can perform simultaneously. Okay, so how can you do it? So can you observe one thing, like suppose there are even before going into this, let me talk about this. Okay, like suppose you have any number, even number. So if you add any number to this, it will become what? 4, which is again a even number. And if you add if you subtract, like suppose 4 and from even number, so we'll again get even number. You can try with any even number, because it's even and odd are in in like alternate manner, no, even odd. So if you plus 2, then you will get the odd parity, and if you do minus 2, and then you can also get into the previous parity of even. So similarly for odd also. So if you have any odd number, if you add the 2 to 1, it will give one even number, and it will again give the odd number. Same way. So we can try this with anything. So it will work for any number which is greater than actually 1. So it will work. So what you can get it, like they are doing the same thing here. They are adding and subtracting. So it's kind of like parity. So it can only happen, like you can change any number to any number unless they are both or both even. You cannot change 3 to 8 by doing these two operations. See this, you can do plus 2 or minus 2, whatever you do, any number is 2, you cannot convert it, never. Or any even to odd number, this conversion is not possible. Hope it is clear to you guys. So they are saying that answer is always possible. See, always, see this, always is this what is essential. So if it's always possible, what does this mean? This is always possible means you can do anyway. Means there should be no even number. If there are, and in both the array, the number of even numbers and number of odd numbers should always be same. So what we can drive here, that number of even plus odd in nums should be equal to number of even plus odd in target. So this is the one condition you have to look into this first. So now Now let's take this question. So how can you do this in the minimum possible? The minimum possible way is possible is when you do either you take two index, any two index, so both two index should have the minimum difference between them. So it will take minimum way. So how can you do that? If you sort the array, so each element of nums and each element of target will have the same, same minimum number of um, difference between the two numbers. So if you sort this number, you will get here 6, 8 and 10, and if you sort this number, you will get 2, 10 and 14. So we can perform the operation between. Now we can do any operation and we can get the result like 6 plus 2. If you do 6 plus 2, 6 minus 2 one time, and you can do 8 plus 2 here. So this is one operation. So it will make 4 and 6 and 10 here. Okay. So this is the one operation done here. Now we have the array 4, 6, 10, and here you have 2, 14, 10. So what is the another step you could do? You could do like 4 minus 2 and it should be plus, sorry, it should be plus 2 is 10. Now why am I writing 6 here? Sorry, 10, 10. So it's already, now it's in place. So we can take these two number now. So 10 plus 2. So 6 minus 2, 4, or you can take these two number. I think these two number will give the result best. 6 minus 2, 10 plus 2, it will be 12. So we have 4, 8 and 12. So if you do one more step, in two steps should be there. Why it's not happening? Let's see. We have 2 and 10. If you take this, so you will get 2 and 12 here. Now 2 and 12 here. 2 and 12. Take 10, 12. Or we can do this 6, 8, 10. Actually, it's for 12 actually. Oh, that's what I'm. Sorry guys, it was 12 actually. Na. Hope you guys might have figured it out. So that's why I'm thinking why it's not happening. So let's erase this part and do again. So let's choose the number. It will get minus 2 and plus 2 here. One operation. So you will get here 4 and here 10 and here 12. So one is settled. This one is settled here. So we can take these two now. We can do minus 2 and plus 2 again. So you will get 2, 10 and 14. So 2 step. So in 2 step it is done actually. So what you got here? If you sort this array, then you will get the between any two number, between the indexer of these two number, there will be minimum difference. Okay. So first approach is like first observation you can make. You can do sorting here, and one more observation like number of even and number of odd number are same as I mentioned here. Okay. If you see this, as I mentioned it already, number of even numbers of in both the target must be same to achieve this goal. So this is the one more condition. Okay, using those two conditions we can do it now. Okay, so what will be the approach here now? Let's see the approach. So what could be the approach here? So we again, if we have array a1 like n1, suppose n1, n2 and n3, so on, and we have another array, we have target array, so t1, t2, t3, so on. So this is the two array. So what we could do, we could firstly sort it. So first operation will sort both the array. Sort, firstly we'll sort it. We'll sort this array, we'll sort both the array. Now after that, just separate the even odd. Why even odd need to be separated? Because we can do even plus 2 to get the again the even number, and odd plus 2 to get the odd numbers. So separate these two, even even number of this and odd number of this en and eo, and for this even number, sorry, odd number. So usually odd number of n num and even number of target and odd number of target. So what we can do now, so we can directly it's the same time we have to do the operation now. So at the same time we have to do the operation. So what we could do now, actually just even, we can take even and we can take odd of this even of this target, and we can perform operation and count it. Okay, any we can run a loop and take every number and increment in this. If this number is like greater than this two, then we can perform en minus et and plus plus the operation. uh, so we can do it like this way. En is whatever the value of indexing value, like index of I minus et of I. We can do both. If this number, the index of this number is greater than this number, we can do the operation, subtraction, and we can do the plus plus. Okay, in this way we'll count the operation. Okay, so how I was saying, like you subtract these two, like suppose this number is 6 here and this is 4 here, so how many operation needed? Only one operation. Oh no, 6 to 4. And suppose this number is 8 here and it is like it is like suppose 2 here. So how many operation? 8 plus 2 and plus 2 again. 8 plus 2 and plus 2 and plus 2. So 3 times. 3 operation needed. So in this way you can do this. So if you do the subtraction, it will give the number of steps we are doing it and divide by 2 here. Why divide by 2 here? So we can make a variable, int res one variable equal to 0, and we can increment this value at this way. Okay, as I explain here, equal to en even number I'm taking about. Okay, you can take any number, doesn't matter. So you do for both and you divide by 2. Why divide by 2 actually? Can you tell me why I am dividing by 2 actually? It's logical actually. And so rest is like 0, and so it is all the operation is counted twice actually. Means one time you do plus, then again one time you do division. So these two are considered as one operation, na? So for making it a one operation, we are dividing it by 2. So this will for even number, whatever the list on even and whatever the list of byte, then we count the count of even, then whatever the array we have, and we can make a function here and count of even. So if both are added, so we will get the minimum number operation here. Okay, what is the minimum operation exactly? So minimum. Okay, this is the minimum operation. So this will be our approach. Okay, this is our approach we're following. We'll be following here. Okay, hope you get this idea. Okay, why 2 is we like one time you incrementing it is for incrementing only, na, and one time you have to decrement also, na, at the same time in the same array. So in this way you can do that. Okay, so hope this is clear to you guys. It's just have to mention with even and odd parity, nothing else. So let's code it out now. So we have this, let's sync it for you. So we're gonna need this for, firstly we have the array name and subject. So first thing you have to do is sort both the array. Now after that you sorting it, create two separate arrays for even and odd numbers. So we'll get two separate array for this. We'll fill this array. Now what's we gonna do? We just write our logic here. Our logic with utility function. So this is with the 3-step we're solving this problem. First sort the array. So how can you sort it? Just directly sort it. Sort nums dot sorry nums dot end. What I'm thinking. So this is for sorting the even list, and then sort the odd one. Sorry, the target one. Target dot begin and target dot odd. Can you make it not? Why I'm writing it like this? So can you make it some simpler? Okay, if you design sub function and apply the logic, so it doesn't matter. Only 2 line is reduced to 1 line only. So you can do this that way also if you want. Single function. Now create two separate array. So as I showed, tell that even number of even number in both the arrays should be same, and number of odd numbers in both the arrays should be same. So how can we do it? So you can declare four vector actually. Vector int, it should be like even number of n1, odd number of n, and then even number of target value and even number of
even odd number of target. So these are the four vector and create. So what can you do for auto I in like suppose nums. So you can do it in one line also. You can if you can check like if modulus 2, then this you can do this way also directly. Ternary function I modulus 2, if this is true then this means it is greater than 1, so it's odd number na, so you can directly push back this odd number of list, not push back what I simply, sorry, symbol should be this way. And if this is not the case, then it is an even number. Okay, if it is true, what does this mean? True means it is returning greater than one value. So whenever the remainder is greater than one, this is mean it is an odd number. So even number. Now if greater than one, it means odd number. Sorry, for this case it greater than one is odd number, and if it not, then it is even number. Now push back, I. So that's it. It's one line, you can do it. Okay, hope it is clear to you guys. On next function, next line, you can write it like this way. So for auto I in target value, to set both the target na. So in the same logic, okay, I modulus 2, then it is odd number. So odd of target dot push back of I, or even dot target dot push back of I. So we have the 4 array with us. So it's time for our logic. Okay, so we have created a arrays. So what could be the logic here? So firstly, we have to count both the number of insertion, number of addition and subtraction in both operation, and divide by 2, then count it. So one better way to display one variable count of even, and pass the even array of both the target. I am writing like this et. So it will count the operation in even or number, and just it will and make one variable or for odd number. So it will count the number of operation of both the odd numbers list. Okay, hope it is clear to God. It's pretty simple actually. Whatever I explained there, I'm just writing in it code. So we have just written this value. That's it. So this is the best way I'm talking. Now we have to design utility function here. So we can design a utility function here. Utility function. So utility function is like why I am writing like this. Actually, it is a 4 way of doing this. So one function we can do this way. You can you have we don't does not have to define the 4 time list. So only 2 time list. Only one time we're passing the even list, and on time passing the odd list, because logic for both them is same. Only 2 plus 2 or minus 2. So it doesn't matter. So that's why I'm making this way. So this is my logic only. So you can do int. Now one more thing you have to be careful here. It's a long returning is long na. So you have to make it long actually. This thing you have to need to clear, or otherwise you will get an error. So count, you can count n, make it n. So sorry. So you don't have to design two function. Count of n, where you pass the what you pass here. You pass the vector na. You just pass the vector here, two vectors. So let's pass these two only. So you pass two vectors here. Vector int list L1, suppose L1, and vector list L2. So we just need two list, and we perform our operation. We declare here long one variable res equal to 0, and just simply int n equal to, you need the size, and most there is one more thing, like L1 and L2. So what will the size here actually? Can you guess it? The size will be same na, because we are even, and the number of even numbers in
the list 1 is equal to number of odd numbers of list 2, and number of odd numbers of list 1 is equal to number of odd number of list 2, or number of even number in the num slips is equal to number of even number is target list, and number of odd number in nums list, it's same as number of even odd number in target list. So hope this is clear to you. So you can take any, actually any length. Okay, so what you can do, just run a loop int I equal to 0, I less than n, I plus plus. You can do one operation here, just res plus equal to s of I. Suppose if it is greater than 0, now you have to mention it here. If L1 of I is greater than L2 of I, so we are taking only one operation and divide by 2 to get the 2 operation, L2 of I. So you can do res plus equal to L1 of I minus, you got getting it now. If this is greater than, you just find a difference here. So L2 of I, it's pretty simple actually, and just divide by 2. Actually divide it by 2. That's it. We have to do this, and after coming out of the loop we just return it. So you might be thinking that you are doing for the greater than only, so you have to be considered here that for each operation we are one will be incremented and other will decrement at the same time, plus 2 minus 2. So in this way it is divided by 2 actually. Okay, for one single operation. Okay, hope you're getting it. It's very simple to return this list. Return this value. So utility function is ready. Let's see, is our logic correct or not. Let's run it first. This is a compilation error is not, hopefully. Okay, compilation error is there. Okay, you have right count here. Okay, so you empty count now. So you can see it's accepted. Okay, let's submit now. Yeah, it's correct. Okay, it's bits, but yeah, space is so much used. Okay, because we are taking 4 vectors here, and time complexity is much higher, because I think for the loops, so many loops are there for the sortings also. So you can do it in one function. Yeah, but still, how can you modify this? Is there any way to do it like the field in same simultaneously? You can do. We cannot do this actually. Yeah. Okay, so this is the pretty much everything about this solution. Okay, hope it is clear to you guys. Okay, so let's close this. So that's all, guys. That's all for today. So hope you enjoyed this video, and hope you are able to understand what I'm whatever I taught here. So if you have any doubt, you can write in comment section. So that's what is, guys. That's the end of our array parts. We have done with lots of questions now, lots of every levels of question, like easy, medium, and hard. Now from for this level, you should be able to tackle any question of array. Now our next data structure is like list. But before going into that, I will show you one of the programming paradigm which is very essential here. That is recursion. So our next topic will be recursion. I will give you some theory part of recursion, then we will do some questions based on that. Okay, recursion is very important here. In data structure algorithm, you must be very comfortable and you must be able to understand recursion to its core. So what I can do, like I will start recursion, then I will do some what I can say, do some the sortings algorithms. I will go make you understand some of the sortings algorithms. Okay, in very fast actually. So I will do the code in Java actually for sortings algorithm. Don't worry. For the Leetcode question, I will always use in C++. It's because it's very fast there. So I will do my sorting algorithms. Show you all the sorting algorithms in Java. And after that, when I get into the next one, linked list, I will again switch back to C++ for the competitive coding or for solving problem in Leetcode. Okay, so language is not a very rare. Don't worry, guys.
So any background can any if you have done any programming language, it's very it is very not that much will if not that much will be hard for you. You will understand it. Okay. So with saying next, thank you for all. Thank you for watching and take care. See you on the next one. Bye.